Last night, you lived an entire second life. You met strangers who felt familiar. You walked through places that don't exist. You felt joy, terror, and confusion as real as anything you experience awake. And then, within seconds of opening your eyes, almost all of it was gone. Most people assume dreams just fade because they're not real. But that's not quite right. Your brain didn't fail to remember last night. It actively erased it. And the reason changes everything we think we know about memory, consciousness, and what your mind is doing while you sleep. Most people assume the answer is simple. Dreams aren't important, so the brain doesn't bother to keep them. But that's not quite right. And the real answer is far stranger than you'd expect, because your brain is more than capable of storing dream content. It does it all the time. We know this for a fact. In sleep labs across the world, researchers have woken up volunteers in the middle of REM sleep, the stage where most vivid dreaming happens, and asked them to describe what they were experiencing. The results are striking. When woken during REM, people can recall their dreams in vivid detail. The colors, the conversations, the emotions, the impossible architecture of dream worlds. Every single time. But wait 15 minutes after the dream ends, and the same person asked the same question will draw a blank. Now, the obvious explanation would be that the brain simply skips encoding dreams. But brain imaging tells a different story. Studies using fMRI have shown that during REM sleep, the regions involved in vivid sensory experience, the visual cortex, the emotional centers, and the amygdala, are firing at a rate that rivals waking life. In some cases, they're firing harder, so your dreams aren't faint signals being lost in the noise. They're cinematic experiences, fully rendered, processed in real time, and then they vanish. To understand why, we need to look at one specific structure deep in your brain, the hippocampus. The hippocampus is the engine of memory formation. It's the region responsible for taking raw experience and writing it into the long-term archive of who you are. Damage it, and you lose the ability to form new memories at all. And here's where things get strange. During REM sleep, when the rest of your brain is staging blockbuster productions, the hippocampus does something almost no one would predict. It goes offline, not entirely, but its connection to the cortex, the network it normally uses to consolidate memories, shifts into a different mode. It's not recording, it's replaying. Your hippocampus, during REM, isn't writing the script of your dream. It's running yesterday's script in reverse, sorting it, filing it, which means the very system you'd need to remember a dream is busy doing something else while the dream is happening. But that's only the structural side of the answer. The chemistry is just as strange. Inside your sleeping brain, the balance of neurotransmitters shifts in ways that fundamentally rewrite what your mind is capable of. Specifically, one chemical drops to almost zero during REM sleep. It's called norepinephrine. Norepinephrine is the molecule of attention. When you're awake and something matters, a sudden noise, an important conversation, a moment of surprise, norepinephrine surges. It tags the experience as significant. It tells the hippocampus, this one, save this one. Without it, memory consolidation grinds to a near halt. And during the most vivid stretches of dreaming, your brain is running on essentially zero norepinephrine. Imagine that for a second. Your brain is generating an experience as rich as a movie, as emotional as real life. But the chemical responsible for marking experiences as worth remembering is simply absent. It's like a film crew shooting a feature on cameras that aren't loaded with film. The performance happens, the footage doesn't get saved. But there's another piece. In 1977, the Harvard psychiatrist J. Allen Hobson proposed what became known as the activation synthesis model of dreaming. Hobson argued that dreams aren't messages or memories. They're the brain's attempt to weave a coherent story out of random firing in the brainstem. Whether or not he was entirely right, his research uncovered something crucial. The dorsolateral prefrontal cortex, the part of your brain responsible for logic, executive control, and self-awareness, is dramatically suppressed during REM. This is why dreams feel internally consistent while you're in them, but absurd the moment you wake. You don't notice the contradictions because the part of you that notices contradictions is asleep. And it's also why you can't deliberately encode a dream. Encoding a memory requires intention. It requires the prefrontal cortex saying, "This matters, hold on to it." But that voice has been turned down to a whisper. So you have a brain producing high-fidelity experience with no attentional tagging, no executive direction, and a hippocampus that's busy replaying yesterday instead of recording tonight. The fact that we remember any dreams at all is the real surprise. The neuroscientist Robert Stickgold at Harvard has spent decades studying this. His conclusion is unsettlingly elegant. Dream memory isn't broken, it was never built. The architecture of REM sleep doesn't include a storage layer. It was never meant to, which raises a question that gets stranger the longer you sit with it. If dreams aren't being stored, what are they actually for? But here's what's fascinating. The fact that dreams are forgotten isn't a bug. It might be the entire point. In the early 1980s, researchers Francis Crick, yes, the Crick of DNA, and Crick Mitchison proposed a radical hypothesis. They called it reverse learning. Their argument went like this. The brain, during waking hours, accumulates patterns. Useful ones, useless ones, contradictory ones, traumatic ones. Memory storage is finite. Without some mechanism to clear out the noise, the system would collapse under its own weight. Dreams, they suggested, are that mechanism. Each night, your brain runs a kind of house cleaning protocol. It activates random memory patterns, evaluates them, and strips away the connections that don't serve you. The dreams you experience are the side effect, the brain's confused narrative as it watches its own deletion process from the inside. Which means that forgetting your dreams isn't a failure of memory. It's the function. The newer research has refined this picture, but the core insight has held up. Modern studies suggest that REM sleep is where the brain integrates emotional experiences, prunes weak neural connections, and stabilizes new learning by erasing the irrelevant. In other words, the reason you don't remember your dreams is the same reason you can remember anything at all. But the strangest part isn't biological, it's philosophical. Think about this. Every night for roughly 2 hours, you have rich, vivid, emotional experiences that you, the waking you, will never know occurred. There's a version of you that lived through them, a version that felt real fear, real love, real grief, real joy, and that version dies the moment your alarm goes off. Some neurologists have started to ask the obvious uncomfortable question, is the dreaming self a different self? Patients with damage to specific regions, particularly the temporoparietal junction, sometimes report a complete cessation of dreaming. They sleep, their brains cycle through REM, but they experience nothing, no internal life at night. They report no change in their sense of who they are, which suggests that the dreaming you and the waking you might be more separate than the connected experience of your life implies. Two different consciousnesses, sharing one brain, separated by a chemical wall that drops every time you wake. This is not an exaggeration. Whoever lived through last night's dream may not have been the same person reading this now. And every morning, that person disappears. Now let's pause here, because this is where the science meets something much harder to explain. You spend roughly 6 years of your life dreaming, 6 years of fully rendered experience, gone almost as quickly as it happens. Not because your brain is failing, but because your brain is choosing. The forgetting is the design. And maybe that's the deepest insight here. Memory has always seemed like the substance of identity, the thread that makes you you. But every night your brain proves that consciousness can exist without memory. That experience can happen without leaving a trace. That you can live fully and intensely in moments that will never become part of your story. Most people assume that what's worth keeping is what gets remembered. But the brain, every single night, suggests something different. Sometimes the most important thing it can do for you is forget. If you found this fascinating and want to keep exploring the strangest mysteries of being human, subscribe to the channel. And in the comments, I want to know, what's the most vivid dream you actually remember? And how long do you think it survived after you woke up? Hit the like button if your perspective on sleep just shifted a little.